tong sa evolution, di ba? There was that first ever digital computer. Okay? So when you talk about digital computer, that means ang data nga gi-process dira are basically digital informations of zeros and ones. Okay? So every time that
Turn
you
off your
input a sound from your microphone, from the microphone padung sa imong sound card, that information of the sound is converted into digital data. Okay? So maka-imagine lang mo, bitaw no, analog man na ako ang sound. But when stored in the computer, mahimong digital, zeros and ones. Okay, yeah. Okay, moagi na gitawag nato nga analog to digital converter. Which is later inyo hara nang magian how it works. Og ibalik. Okay? Now, talking about the so-called zeros and ones. Okay, so let's just have a common um, term of how to call them. So let's say when you're talking about the computer's memory, it is usually divided into tiny storage bit location known as bytes. Okay, so take note when you talk about bytes, it's basically consists of 8 bits. Okay, so are we familiar with this, guys? Bits. Okay, so usually, di ba, when you try to look at the specs of your memory, be it the RAM or the ROM, it is usually in GB, MB. So B there stands for bytes. So when you talk about speed sa imong internet, okay, unsa may gigamit ana, guys?
Gigabytes.
Okay? So moingon ka bytes per second? Is that bytes per second? Okay? So it's more of bits per second. Okay? Ang iyahang unit of measurement. So usually when you talk about bytes, you are just referring to 8 bits of data. Okay? So, more na si bits, guys. So, you have there so-called on and off, which is basically when you say on and off, mura ra na siya equivalent to 1 and zeros. Okay? So, inside your computers, kanang mga transistors ni mo dira are acting like switches. But of course, unlike mechanical switch, they are controlled electrically. Okay? And they can be jam-packed into a small space, unlike the mechanical switches. Okay? So imagine with your processors right now, there's like a million transistors, okay, in a single chip. Okay? So we call 8 bits equivalent to a byte. Okay, now I think maragwa na ako ma-appeal dire. There might be some scenarios wherein you will encounter this. Okay, so what if 4 bits? How do we call it? Okay, when you say 8 bits, we call it as a byte. Okay, but if you have 4 bits, what do we call it? Okay, okay, you call it as a nibble. May kaya kay mo ni gamit sa kung ano, kung naa diri sa online ba kay dali ra jud kay maka-Google. Okay, so mo nang sa akong style karon di kay kumuhatag diretso. I let you search. Okay. So, na may idea, guys? Nganong nibble? Nganong nibble man ang 4 bits. Kung 8 bits, 1 byte. Okay? Could you kuan can you do you have an idea? Do you think you can um, how do you call this? Provide an explanation as to why you call it as nibble? Okay? Okay, di kayo dako og paak. Kay kung 8 bits is 1 byte, nga wrong spelling ang byte, So kung ginamay lang 4 bits, so we call it as nibble. So inkib lang, di ba? Gamay lang ang inkib, nibble. Okay? So there's also the so-called kwan guys, in the computer terminologies. Kanang gitawag na to nga one word. Okay? Which in some computer is around 16 to 32 and other some abot 64 bits. But actually, this would vary depending on the system. Okay? So, unsa ko na tawag? Pabebe byte. Okay? So, di na pabebe byte. It's called a word. Okay? So, they call it a word because kaning gitawag nato nga 16 bits, 32 bits, 64 bits refer to the number of bits that is required to create one instruction. Okay? So, manang gitawag siyang one word. Okay? So, mana mga terminologies later on nga maagian pod ninyo when you will be moving into the higher years of computer engineering. Okay, but for now, let's just focus first on bytes and bits. Okay, so kana si nibble di kayo siya common na term. Okay, o kanang word. So usually when the subject becomes more specific, ana-ana na mo ma-encounter si nibble o si word. Okay, so karon, do we have an idea na how data are stored in the computer? So they are stored in an on and off state. Okay, that we call as the bits. Okay, so storing numbers. Okay, so how do we store numbers? This so-called byte in your computer. Okay, so they are arranged in zeros and one. But unsa man ang zeros and ones? As what we can see there, okay, this is the so-called what number system? Tanawa. That is base 2 nga number system, which is also commonly known as the paspasa maka-Google sumalinog oy. Binary code. Okay. So kani ding ato ang number system nga gigamit unsa man day ni? Kanang 1 2 3 4 5 6 7 8 9 10. Okay? Oh.
Decimal.
So we call that decimal, and the reason we call it decimal guys is because the number system that we are using is using base 10. Okay? Now, kaning nakita ninyo, unsa man ni? 2 raised to the power of 0, 2 raised to the power of 1, 2 raised to the power of 2, 2 raised to the power of 3. What are those numbers? Okay? So those numbers are what we call as the weight of the number. Okay? So I think when you talk about the decimal number system, what are the weight of the decimal number system? Gikan sa smallest to largest. Let's say, if you have a number, di ba, you have numbers on the positive side, which is on the left side of the decimal point, and you also have numbers on the decimal side, on the right side of the decimal point. Okay? So, if you have this so-called number system, let's say decimal number system, if you want to know the weight of the number on that position, you simply do this. Until 10 raised to the power of m. The same is true for the numbers on the negative side. 1, diba? 10 raised to the power of 2. Until 10 raised to the power of negative n. Okay, what does that mean? Okay, what is 10 raised to the power of 0? 1. And what is 10 raised to the power of 1? 10. And what is 10 raised to the power of 2? 100. What does this reminds you of, guys? Okay, number of zeros. Okay, yes, in a way, they refer to the number of zeros. Exponential growth. Wow, pang high level na jud kay ta. Okay, move backward pa jud during your elementary days. Let's go back to the basics. Okay. How do you call this again? One, s, 10, s, 100, s. Di ba? They refer to the place of the number. Okay? So, the place of the number basically tells you the weight of the number. Ang iyang value. Mo na siya, place value or the so-called weight of your number. So, those numbers nga maingon kag naa diri sa right side sa decimal point, di ba? This now becomes tenths, which is hundreds na na th. Okay? So, as you can see, the farther away you are from the decimal point on the right side, the smaller the number becomes. And those numbers farther from the left side of the decimal point, the bigger the number becomes. Okay? Now, with that idea in mind, guys, okay, mao day na gibasihan sa kanang gitawag nato nga positional weight of a number. Okay? Having that in mind, what do you think is the value of this binary number that we have here, or this byte? Okay, can you solve it? How to convert that binary number into a decimal number that we are mostly familiar of? Okay, so how do you convert that binary number into a decimal number? Again, that's as simple as adding the weight of the number. So it's just like 1 times 1, di ba? Kay 2 raised to the power of 0 is 1. 2 raised to the power of 2 is 2. 2 to the power of 2 is 4, 8, 16, 32, 64, and 1 to 8. Okay. So adding them up, you'll have, pila na siya? 157. Okay? So hopefully, wa mo mo gamit o calculator. Okay? Though we can easily use the calculator for that, but it is also good to know that you should know how to convert it, okay, using paper and pen. Okay? So nasabtan na guys ang conversion, okay, from binary to decimal. Okay? So this is actually also applicable with other number system. Okay, so let's say for example, mingon ko kwan guys, 1, 2, 3, which is base 4. Unsa equivalent ana niya in base 10? Okay? Sige daw. Patay, wala man na sa calculator, sir. How to solve that? How to po? Okay? So, sige. Use that same concept of positional weight. What is the answer? Okay? Could someone give me the answer for this? It's taking time. Okay? So, how to solve this? Nay, nag-solve, guys? Come on. Can I have some answers for this? Hello, people. Maju, you still there? Sige na, solve sa ninyo eh. Okay, sige. Let's try to call. Okay. This is much better. Okay, let's put it in a whiteboard. Okay, so everyone is here, 32 people. I'll give you the opportunity to edit it. Okay. So on the chat box, guys, okay, we have there the so-called Jamboard. Okay, were you able to connect? Okay, is everybody connecting in our Jamboard? Okay, so ako asang gi-off ang share screen so that everyone or I can see everyone. Okay, wala pa na ako ma-install sa grid. Okay, so pwede mo musuwat diri guys. Okay, so you can write your solution there. Okay, so for those who are using computers or cell phones, so nindot sa cellphone kay touchscreen, it's just like having a graphic pen. Sige, let's see if you got the idea of how numbers work. Okay, so kato kong gisulti kanina guys, using the positional weight method. Okay, we use that when you are converting a base number that is not base 10, because the result of using the positional weight is always in base 10. Okay, or you could say that the weight of the number
We're doing
is
base tables.
base 10.
In our normal everyday
Okay, so
world,
here
we
we
work
have
off of base 10.
4.
Base 10 is
So
every
if you
time
convert that
you go to a
into
place value to the
base
left,
10,
you multiply it
which
by
also
10.
is equivalent
1
to the
times
weight of
10.
the number, what is the value?
10 is
Okay,
inside to the right. Base value here would be, and then the multiplying, except not by 10, like the base 10 does, we're multiplying by 4. And that tells us right here what our columns are going to be. This is what our place value columns are going to be.
So ang uban
So
wala
let's take
pa'y
a look.
Jamboard. So
So
mao din no ang
each place value is multiplied by 4, and you're only allowed to put one number
okay,
into
nung
each
si
box.
Kabos, unsa to ang
So we
i-convert
go
sir? 1 to
from
3 base 4 to
1s
base
to
10?
4s
Yes,
to
that's what
16s
has
to 64s to
been shown on the
256s
Jamboard.
to
Okay, so na may uban
1024s.
day wala pa ka
And then to the right of the decimal place, we have 1/4
install og
and
Jamboard. Sige, ato na
1/16.
lang
Now normally
i-share
that
ang
would be the
screen para
10s place,
makita
wouldn't
po
it? And
sila
that would be the
sa
100s place.
pag-answer sa
But
uban.
because we're in base 4,
There you go.
it can't be bigger than 4.
Okay, can you see it na
Okay.
guys?
So if I wanted to write the number 5, I would have to put 1 4 and 1 1, and that would make 5. So in base 4, an 11 would really be 5. Is that confusing? Check this out. How would you write 17? You'd have 1 16, no 4 16. You'd have 17. You'd have 1 16, no 4s, and a 1. That's how you would write the number 17.
Okay,
See?
so guys,
How would you
come
write
on.
the number 66? You'd have a 64.
Okay, I'm not seeing any
You'd
movement
have
on the
no
Jamboard.
16s. Now remember,
There
we're going
are
for 64s.
14
Add 2 more.
students here in the
2 is
Jamboard.
how you
Can
would
we
write
see
the
how
number
you are solving
66
it?
in base 4. Isn't that crazy?
Okay. So in a way, we also need to learn how the computers think. Okay. So usa ni siya sa ato ang dapat mahibaw-an. Okay. How the computers actually think in converting numbers, because everything that you store inside your computer are all numbers. Okay. There we go. And so take note on the positional weight, tanawa diri guys. After the period, on the left side, it starts with 0. On the right side, it starts with -1. Okay? Kaluoy. Wala mang gamitang eraser. Okay? So ako'y gamit sa eraser, erase na ko. Na may eraser, pwede ra ma-erase, gi-crash or yun. Okay. there you go.
So the number 20 would be written like that. The minute you get to 3, you have to go to
So,
that
muna,
column.
4 raised to the power of 0.
The
Automatic. That
5,
is
4 to
1.
the right of the decimal place.
Okay, so you have 1, 4, and 16. Okay. 1. Okay, so 16 plus 8 plus okay, nindot isuwat sa kuano, cellphone. Okay, luyas ang naggamit og mouse. Okay, there you go. So 16 plus 8 plus 3 and that is 27. Okay? So let's say 27, i-convert nato into binary. Sige daw. How do you convert 27 into binary? So sige, let's try this out. Since ang computer, binary man kayang basihan, so it would also be nice if you know how to convert, okay, a decimal number into binary. So the answer here is 27. Okay, so how do you convert that 27 into binary, guys? Sige, how do you convert 27 into binary? Pabaliktad na sad, no? Okay, now the easiest way to do that, guys, is again binary weight. Okay, oh, very good. So pwede nimo ilista daan ang weight. Okay, so pwede na to. Ito ilista diri ha. 1, 2, 4. Akong tiwason, 8. Auto ra day. Sige. Abi na ko giundangan. Sige, go ahead. So 8, 16. What's next? 32. Okay, do you need to proceed? No more. Don't proceed anymore to 64. King ano man. Sa pagtanaw pa lang nato sa weight daan, it's 27. Wa na siya kaabot sa 32. 32 cannot represent 27. So tangtang na ni sila sa imong conversion. You won't be needing that. So that leaves you with a weight of 16, 8, 4, 2, and 1 to represent your number. Okay? So, ang answer niya diri is pila? Okay. So how did we do that exactly? Can 16 represent 27? Yes. So you minus 16 to that number, giving you 11. 11. Can 11 be represented by 8? Yes. So you put 1. So you minus 8. Okay. So you have 3. Can 3 be represented by 4? Eh. So you put 0. Okay. So can 2 represent 3? Yes. So 2 becomes 1. And lastly, can 1 represent 1? Obviously. So 1. So this is, guys, your base 2 answer. Okay? And that is your decimal to binary conversion. Again, using positional weight. Okay? However, the computer has its own way of converting decimal into binary, which is much more easier for the computer to do. Kaning inganing positional weight, nindot ni siya gamiton kung ang tao mag-solve. But kung ang computer mag-solve, it is difficult to create a program that will perform such a function. Okay? So ang computer, how does the computer convert, okay? Tawag ani? Decimal number into binary. So I'll just clear the frame, ha? Okay? So here is what the computer do, guys, when converting. It uses an algorithm called repeated division. Okay? So what the computer actually does is it divides the decimal number with the base. target. So this is applicable to any number system as long as gikan sa base 10 to any base number. So let's say 27 divided by 2 pila guys.
13 remainder 1.
Okay, so you have 13 remainder 1. So dinhi mo himuong 0.5. Okay? Ang remainder ipadapli na to. So since it is called repeated division, you divide 13 again by 2. Okay? O sige. Could someone continue this process?
Can I, sir?
O sige, go. Go ahead. Okay. So you don't need to draw the line. Idiretso na lang. Okay? O take note, ang number nga i-divide, okay, would be the quotient from the previous step. Okay. So there you go. 6 divided by 2, you have 3. Okay. And there is no remainder. Okay. So take note, no remainder. So you should also put gihapon 0 that there is no remainder. Sige, padayon. So 3 divided by 2. Okay, lahat na yung padayon. Oh, so teamwork sila. Okay. So you have last is 1 divided by 2. Okay, is equal to
0 remainder 1.
0 remainder 1. Okay. So the moment you reach a quotient of 0, you stop the process. Okay, so take note. The moment maabot na nig 0 dire sa quotient, stop na ang process. So that means this is now your final answer. As you can see guys, when you are talking about number system, expected ang representation for each digit of your number system will never go beyond the base. Diba? When you say base 10 or the decimal number system, ang number mo represent for each digit, di jud na mula pas sa 9 or di jud mula pas sa 10. 9 rataman. With base 4 ganina, as you can see, I'm only using numbers 1, 2, and 3. Ug wa ko mogamit og number nga 5 because that is not a valid base 4 number. So the same is with binary number. When you say binary number, that is base 2. Dili ka mulapas og 2 nga digit. It could be less but not equal. Okay? So from this, unsa man ni nato paggamit kaning remainder? As you can see, ang remainder nato when you do repeated division, the remainder will never be beyond the base number, which is actually ato ang target. Now, how do I get the final answer? To get the final answer, you just okay, rewrite the steps, making the last remainder the most significant bit and the first remainder the least significant bit. So the result ani niya is 1, 1, 0, 1, 1. Okay, which is on base 2. Okay? Na kita ninyo guys how conversion is done. Again, these steps is applicable not just to base 2, but it is also applicable to base 4. So again, 27 divided by base 4. Okay? Could someone continue this? Okay? Using repeated division. Okay? So para mapakita na to and we can prove that it really does generate the correct answer. Okay? Okay, that's it. Okay. O nilagman kamay. 1 divided by 4. Wala gitiwas ah. Okay. So that is 0 atura. The remainder. Okay. So remainder 1. Oh, hinay kayo da. So, as you can see guys, ang answer na to is 1, 2, 3 and that is on base 4. Diba? Same ra sa given kanina. Okay? Now, let me show you comparison lang ha using positional weight. Okay? So, if I'm using positional weight, pila ganito yung weight? 1, 4, and 16. Okay? So, that is how we use positional weight. So, tanawon na nimo. When using positional weight, you have there 27. Oops. Sorry. 27. Can I use 16 to represent 27? Yes. So, minus 16. Okay, so you have 1, 11. Can 4 represent 11? Yes. So, kung minusan ni mong 4, pilan lay mabilin? Okay, so you now have pila? So, you now
7,
have
sir.
7.
7, sir.
Okay. Can 7 still be represented by 4? Yes. Minusan na po ni mo laing 4. So, that gives you 3. Can I still represent 3 with 4? No. What will I use to represent 3? Minus 1. Minusan na po ni mo og 1. Minusan na po ni mo og 1. So, kapila ka nag-minus og 1? Katulo. So, you put it here. Kapila ka nag-minus og 4? Kaduha. So, you put it here. And that is how you do, guys, conversion from base 10 to base 4 using repeated subtraction. So, as ay mas dali, repeated subtraction or repeated division. Ang uban maingog subtraction sir kay
Division.
basic ra man
Division,
kayo.
sir.
Pero mas dali ang division. Okay, mas mubo ang process and that's why the computer is using that for conversion. Mas mubo ang process. It takes shorter, okay, time to finish the conversion. Okay, so I think that's it for now, guys. It's already 12 o'clock. Padayon yata next meeting. Okay, so but before we go, can we again turn on our cameras, please, for our attendance? Okay, so stop lang na ako ang share screen ha. Okay, so ako na lang ning appeal sa ako ang screen ang last discussion para makabaw ko asa tama na nga to ang discussion kay malimot na pud niya ako. Okay. Okay, so kinsa pa iwa mag hantud karon ngit-ngit paghihapon ila Miss Albarasin. Natug paghihapon mga tao dira Miss Albarasin.
Ay, wala, sir.
Aw,
Wala ko nag-on og lights, good.
okay.
Sakit daw sa mata, sir.
Cost cutting, cost cutting. Uy, may nag-show sa likod.
Yo,
Ayun.
kama sa mo.
Okay, so mani kuyaw sa dani no, ma Cesar Montano niya ta ba? Okay. So we are still waiting for Rhea May, Miss Rhea May Tuto. Before we take our shot. Asa man si Miss Rhea May Tuto. So again guys, for those who haven't updated their profile pic yet sa ilahang Gmail account, please do update your pictures now. Okay, so at least i-background ninyo white sad para murag ID picture gyapon. So again, I think that would also be required by some of your teachers niya sa klase. Okay? So i-update na lang na daan. So at my count, 1, 2, 3, cheese. Okay. So, that's it for now, guys. Next meeting, let's proceed with our discussion. Magsugod na ta sa atong discussion on flow charting and algorithms. Okay, so one more step towards coding and programming, or rather programming slash coding. Anyway, maura pa na siya. So, maura to. Without further much ado, goodbye, good day, and God bless everyone. Bye-bye.
Yes, sir.
Bye,
Bye,
sir.
Bye, sir. Thank
Bye,
you, sir.
sir.
Bye.
Bye, sir.
Sir.
you.
Thank you, sir.
Bye, sir.
Thank you,
God
sir.
bless, sir. Thank you.
Bye.